Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So hi everyone, in this video we are diving deep into the Node.js streams and how they manage the memory under the hood. So that is the main concept which we will try to see. Especially we will focus on the buffer sizes, stream back pressure, and how you can optimize your app performance. Let's try to see it. So first of all, let's try to see. We are dealing with a problem around a stream memory usage, right? So in the previous video we have executed this program and we have seen that the memory is taking around 150 MB. Let's say that we will try to run it, and so that you can able to see it very clearly. I hope that you will be able to see this screen also, this command prompt also. Node write more.js file. Okay, I'm running this program, and in the task manager if you try to take it node, so it is taking the memory around 1000 something around the memory has been taken. So that means it is taking around 1 GB of memory space for writing a simple code, and here we are writing this one, right? So it is taking, and if you try to see it, yeah, here it still is taking. So the completion has been completed. Now if you try to see here, the memory has been dropped down. If you try to run it again, let's try to see it again. And here the Node.js went, it is going to around 1000 MB. That is nothing but around 1 GB. 1 GB it is taking. So that means we have a problem when we are using the streams. The memory usage is the problem which we are having it. The CPU usage is less only, but it is taking this one. So let's walk through how Node.js manages this internal buffer and how we can monitor and fix these memory issues. We'll try to see it. So that is the main agenda which we need to work on. So first of all, what we'll try to do is we'll comment our existing code and start fresh. So I will be commenting out this existing code. So this entire code I will comment it out, because what we need to do, we want to analyze the behavior of the internal buffer in a writable stream. So here we want to analyze the behavior. So fine. Node.js doesn't officially expose the internal buffer of a stream, but it gives us two helpful properties, that is nothing but writable high watermark and also writable length. In our previous video, if you try to see, I have told you that whenever you are having a writable stream, internally it will have some buffer. So when whatever the stream data it is coming, it will store it in the buffer. When the buffer is full, it will write to the file or anything, and again it will try to take the data. So by the time when the stream is coming means the data will be stored in the memory. So here we need to know what is the size of this internal buffer. So now the default size of this one is, so if you want to know it means, so we can use variable that is nothing but console.log stream dot high writable high watermark. So this will give you the total size of the internal buffer. Now if you try to show you the total size of the internal buffer, that is around 16384 bytes. That is nothing but 16 KB. Okay, it is around 16 KB. And now you need to know how much of the buffer is currently filled. So how much of the buffer is currently filled means in the stream, you will be having the internal buffer in the stream, right? So the maximum size of this internal buffer in the stream is 16 KB, and how much that stream has been filled, if you want to check it means, so we have another property in the stream object, that is nothing but stream dot writable length. Okay, so this will give you that how much data has been filled. So out of that 16 KB, how much data has been filled? Right now we haven't written anything, so that's why it is showing 0 bytes. So for example, let's say that I have written something like constant buff is equal to buffer dot from. So I have written some data. So my name. So it is around 1, 2, 3, 4, 5. Okay, it's 5 bytes. So each one will take 1 byte. So now here, okay, let's try to check the writable length. So we will write that buffer into the stream. So stream dot write of buff. Okay, we have written. Now let's try to see how much data it has, how much bytes it has taken. So if you see here, the 5 bytes it has been taken, and if you want to print the buffer, console.log buffer, okay, now if you see the output for this one, so you will be able to see the data has been written in a hexadecimal format. That is nothing but 6C means it is L, E, E. So that's why 65, 65, L and also E. So that's why this 6C is same, 65 is same, and 61 is the last one. So here the data is storing in a hexadecimal format. Hexadecimal format means nothing but it's an what I meant to say is it's a binary digit only. So this one represents the 4 digit and this one represents the 4 digit. Total 8 bits. It concludes with the both of them combined. It will become 1 byte. 1 byte, 2 byte, 3 byte, 4 byte, and 5 bytes. So that is how you need to calculate in the buffer. So this is all totally related to the memory issue, and this all we are dealing with the binary data. So think of it like that only. So when you are converting this L means, so think of that one we are converting into an 8 digit. So it should be something like let's say that L should be in such a way that 0 0 0 0 and 0 0 0 0. So here you can write 1 or something like that. So depending on that one. So that is the thing. Okay. So by default the stream is 16384 bytes, that is 16 KB. You can change it, that one. If you want to change that 16 KB means you can change it, but you rarely need to unless you are building the custom streams. So we'll try to see about that one also. So that is the thing. So we have written the data to our stream, not just a string but a buffer made from that string. So this will help us to visualize what is going on. So now after writing this one, we have seen the writable length. It has become 5 because each character takes up to 1 byte, and when you write the same buffer 5 times, the length will jumps to 36 something like that. So here let's say the 25, sorry, 2 3 4, oh sorry, not this one. Here I will write 1 2 3 4. So 4 5s 20. Let's see the output for this one. So it should jump to 20. So it's correct. So the stream has filled with 20 bytes. So this is how you will need to understand about this one. So now here the crucial part comes. So once the writable length reaches the high water mark, so that is nothing but the writable length reaches the high water mark. So that means when it reaches the 16,384 bytes, when it reaches, Node.js signals you a back pressure. So that means the buffer has been filled. So if it is then when you are trying to write this one, it will return the false. So where it means the internal buffer is full, and you should pause writing until the buffer drains. So this one we will try to see afterwards. So now we have seen, let's talk about the memory once. So now here we have seen this one. So first of all, what we will try to do, so now we need to create a buffer which is of writable high water mark. So now how we can create the memory buffer with a particular memory by using the buffer.alloc. For example, let's say that, so if you want to create it means buffer.alloc of whatever the memory you want. So for example, let's say that you want to create 10 bytes, and also I want to fill it with 10. So now if you try to console.log with buff, so now you are creating a buffer, you are creating a buffer of 10 bytes of memory, and you are filling the data with 10. Let's try to see. So if you try to see here, so all the values is filled with 0A. 0A means it's a hexadecimal representation of the binary values. So 0A is nothing but 10 only in the binary. So now we have created a buffer with a memory of 10 bytes. For example, if I want to create a memory of 100 MB, then what we need to do? 100 MB means, so it will be something like, if you want to search it means you can search it like this. So here you can search it something like MB2 bytes. Okay. So if you search it like this, so here I want to have a 100 MB. There is nothing but 1E plus 8. So this is nothing but 1E means, so 10 to the power of 8. 10 to the power of 8 means, so 1 with followed by 8 zeros. So if you want, you can also create something like, here you can go into this one, and you want to create 1E plus 8. You can write it like this also, not a problem. So now it will create 100 MB. So now here if you try to see the output for this one, let's see whether it will create it or not. So here you will be able to see it has been created 100 MB of space. So if you want to check that you are creating 100 MB of space means, so now I will try to use set interval. Okay, I will create 1000 like this. So now if I run this code, Okay. So now we have created a buffer, internal buffer memory. I want a memory of 100 MB. Now if you go here and if you try to see the Node.js, you'll be able to see 100 MB, 103 MB has been taken memory from the RAM. So that means a buffer has been created within 100 MB. So this is how you bring. So now the memory usage spikes immediately. So we have seen that memory usage spikes immediately. And when the buffer is no longer used, Node.js garbage collector will eventually clean it up, and which you can observe the memory drop. Now when it is not useful means, so if you remove this one, so automatically the memory will be gone away. So that is the main thing. So this is how you can able to see the buffer. Using this buffer concept, we'll try to implement this one. So you need to understand that here 8 bits is equal to 1 byte and 1000 bytes is equal to 1 kilobyte and 1000 kilobytes is equal to 1 MB. So like this. So 100 MB means 100 into 1000 into 1000, that is nothing but 10 to the power of 8 bytes. And if you log the buffer, you will see hexadecimal values. Each hexadigit represents 4 bits. So here each hexadigit number represents the 4 bits. So that's it guys about this one. So one final tip before closing, always close your file after you are done. So in this file, in this code, what we have did, so we have opened this one, but we have forgot to close the file. So here at the bottom also we are not closing it. So what you need to do, so we need to file handle dot close. Okay, so if you are manually opening the file means, so always remember to close the file. So proper cleanup is essential to prevent the resource leak, especially in the production environment. So to wrap up, we saw how Node.js streams manage memory, how to monitor and control buffer size, and how to handle the back pressure effectively also we have seen it. So if you like this deep dive, give it a thumbs up, subscribe, and let me know in the comments what you want to learn. So that's it guys about this one. So see you in the next video. So we will try to understand this streams and back pressure and all those things. Thank you.